Hi everyone, today I'll be attempting to derive the Marshall-Lerner's condition. So what does the Marshall-Lerner's condition state? It states that when the absolute value of your price elasticity of demand of exports plus your price elasticity demand of imports is greater than 1, a currency depreciation will lead to an improvement of the current account. Now, what does this mean? It means that when an economy's currency depreciates, the balance of trade surplus can increase or a BOT deficit can be reduced. Now, this is different from, let's say, an expansionary monetary policy where we look at how the aggregate demand of the economy is impacted. Because here we want to account for prices of exports and imports. Now I'll be assuming that you have a basic knowledge of elasticity concepts before I continue the analysis. Now, first of all, what we have to do to prove is to write an expression of the surplus, which I'll be using S to denote. So S will be equals to price of exports times quantity of exports, which will give you the export revenue, minus price of imports times quantity of imports, which gives you the import expenditure. However, this expression is not complete because we have to do everything in terms of domestic currency in order for the values to be appropriate. Now, the PM here is not actually in terms of domestic currency because when because you're buying goods from overseas and bringing them into your country. So what you need to do is multiply E, which is the exchange rate. So E here refers to the price of a foreign currency in terms of domestic currency. So now, another thing that we have to do before we continue the analysis is to normalize all prices to equal to 1 so that we can simplify the analysis. So we can continue with our expression for S. We can rewrite it as QX minus EQM because now all prices are equal to 1. Now let's remember what we are trying to prove. We want to prove that change in E will impact your S. So to do this, we have to differentiate our surplus with respect to the currency, to the exchange rate, so DSDE. So when we differentiate this, we get dQX over dE minus. So for this term, this EQM, so what we need to apply is your product rule. And what you get is E dQM over dE plus QM. And we expand out the bracket, we get dQX over dE minus E dQM over dE minus QM. So before I continue, I would like to highlight the mathematical concept of elasticity values. So let's say you have a price, this will be going back to microeconomics. Let's say the price elasticity of demand of a good refers to the percentage change of quantity divided by the percentage change in price. Because you want to find out the responsiveness of a change in the responsiveness of a quantity of a good with respect to a change in price. So this will be actually del Q, which is change in Q over Q, which is a percentage change in Q, divided by del P over P, which gives you del Q over del P times P over Q. Now that we have this expression, we can continue this line and try to work towards having PDX and PDM. So let me continue writing out. DSDE will now equals to, one way we can get from this expression towards PDX and PDM is to factorize a QM outside. So let's factorize QM. So we get 1 over QM dQX over dE minus E over QM dQM over dE minus 1. Now can you see this term over here just corresponds to PD of M because del Q over del P times P over Q, which is the reciprocal without the delta, will just be the price elasticity of demand. So now that we've gotten this, we can rewrite it as Qm times 1 over Qm dqx over dE minus PEDM minus 1. Now, we have to find a way to express this value here in terms of PDX. So one way we can do this is to multiply Qx over E with E over Qx. So you realize that this term here is just, let me write the x nicer. This term here is just a 1, which is why it doesn't affect anything. So continuing the rest of the expression, minus PDN minus 1. Now we see we have Qm times Qx over EQm times PEDX minus PEDM minus 1. Here, we may recognize what this term means because this is similar to what we have here. So now what we have to assume is that the initial trade surplus is 0, which means that Qx equals to EQm. Now, continuing from here, we get Qm multiplied by PEDX because EQM equals to Qx, so the ratio will just be 1. So minus PDM minus 1. Now, to continue, we have to analyze the signs of PDX and PDM. Now, one might think that, let's say, depreciation will lead to price of exports to decrease because now, with a currency being weaker, a foreign economy's currencies will be stronger than ours, and thus the prices of exports to them will decrease, and this will lead to a rise in exports expenditure. This is correct. However, you might conclude that thus when E decreases, your X will increase, and thus the dx over dE value will be negative. However, this is incorrect because when your E decreases, E refers to the price of foreign currency in terms of domestic currency. So when your E decreases, the price of foreign, let me just write FC, foreign currency in terms of domestic currency decreases, which actually corresponds to a currency appreciation of your own currency, appreciation of domestic currency. Now, does this make sense? Because when your currency appreciates, it becomes stronger, and thus the price of the foreign currency in terms of your domestic currency will decrease. So now let me just highlight this concept again because it may be a bit confusing. When the price of foreign currency in terms of domestic currency falls, your 1 unit of domestic currency is now able to buy more foreign currency because foreign currency is now relatively cheaper. And thus, 1 unit, the original 1 unit of domestic currency can now buy more foreign currency, which means that your domestic currency has strengthened. And thus, it refers to an appreciation of the domestic currency. Leads to the price of exports to increase and the price of imports to fall, leading to export revenue to fall and import expenditure to increase. So now we see that when E falls, X falls, which is the same directional change. And when E falls, M will rise, which is a different directional change. So this implies that dx over dE is positive, and dm over de is negative. This will work when you think about it when e rises, and then I'll leave the viewer to do this as an exercise for him or herself. So now we can see that from here, this expression here can continue. Qm, I'll just rewrite it, Qm pdx minus pdm minus 1. We can tell that pdx, as proven earlier, is positive and the pdm is negative. So when you take the, when we want to find out this value, when we go back to the original goal, we want to find out that depreciation leads to an improvement of your current account. Thus, depreciation means that E will rise, and improvement here means that S will rise, and we want DSD to be a positive value. And since QM here can be a constant, a non-negative constant, we just have to focus on the sign of PDX minus PDM minus 1, and we want it to be positive. Now, moving the 1 minus 1 over, this has to be more than 1. And as proven, PDX is positive and PDM is negative. So, when we work in terms of the absolute values, we get PDX plus absolute value of PDM more than 1. Now, let's work with some values in an example. So let's say PDX equals to 0.6. And keep in mind, these PD values has to be between 0 and 1. Now let's say PDM equals to minus 0.6. So the absolute values is 1.2. Sorry, the sum of the absolute values is 1.2, which is greater than 1. Now we can substitute this thing into this part here, this term, and you can see that 0.6 minus negative 0.6 minus 1 is more than 0, which is why DSDE will become positive, which is what we want to achieve. So we can see that when the absolute value, which is 0.6, and the absolute value of this, which is 0.6, the sum is more than 1, we get what we want, which is the Marshall-Lerner's condition. Now, giving another example, let's say PDX is 0.4 and PDM is minus 0.4. Okay, 0.4 minus negative 0.4 minus 1, which is, by the way, if you haven't figured out, this is 0.2. This would be negative 0.2, which is less than 0. Is why when it doesn't satisfy the Marshall-Lerner's condition, there will be a negative DSDE value, which is which is a deprovement in the current account. So here we have managed to prove Marshall-Lerner's condition, and if you have any questions, feel free to ask me in the comment section or whatnot. Thank you for listening.